So let's get going. What are we doing at the moment? We're doing circle geometry. And we're going to carry on in a moment with the types of questions that we were doing in the last lesson. But before we get going, I just want to think about three main kind of areas that we can divide the theorems up into. So when I think about this, I think about the theorems that deal with circles and the center. Then I think about circles and cyclic quads. And then I also think about the theorems that deal with circles and tangents. So in terms of the questions that we're doing, it's important to do a quick little scan when you start a question and see, is there a circle, and then is there a tangent to that circle? And does that tangent connect to the center of the circle, or does that tangent have a chord that it is connected to? Does that chord subtend another angle? So these are the types of things you'll be scanning for. Or in circles and cyclic quads, you're looking to see, well, is there a cyclic quad? And what's the cyclic quad? It's just a quadrilateral where the four vertices are on the circumference. And you need to know that in a cyclic quad, the opposite angles add up to 180. Or you also need to know that if you have an exterior angle of a cyclic quad, it's equal to the interior opposite, which is here. And there's a couple of other, a couple of ones. And in this one, there's probably the most famous one is that the angle at the center is twice the angle at the circumference. So maybe if you had something like that, this would be 30. Another common one is the angles in the same segment. So if you have, so we have 2 points and we make an angle there. You can see these 4 points here. Sometimes they call it the butterfly theorem. This angle is equal to this one, angles in the same segment, and this is equal to that one over there. Well, let's make it a different symbol. So I just want you to have that in the back of your mind as we engage with the questions today. Give me a thumbs up if the three buckets, I call them the 3 buckets for circle geometry, make sense to you, or they look familiar. Give me a thumbs up, and give me a thumbs down if you feel like, no, I'm not really aware of these 3 buckets. Let's call them 3 buckets of circle geometry. Okay, so let's get crack-a-lacking with what is going on. So let's start with this question over here. And in this question, I want in the chat people to tell me what buckets are involved or what facts might be involved. And then after a little while after that, I want you to try and tell me what F and what G is. Okay, you can start working on it, but I'd love some stuff in the chat about what information might be involved or what theorems might be involved in this particular picture. So Mwanzile has recognized something, that there are tangents afoot. What type of tangents do we have here? So we might have the tan chord theorem, but I'm also seeing this point B, and a tangent comes from here, and there's also a tangent that comes to there. Let me actually get rid of this. And what we would say here is that these are tangents from a common point. That common point is B, and there's a theorem that deals with this, and it says that AB is equal to BC. The reason is it's tangents from a common point. From a common point. So that's the one little hint I'll give you. There might be other things involved, but for the moment, we know that this actually is an isosceles triangle. Now, we still need to try and work out what F is. Now, F is the angle down here. Maybe somebody can raise their hand and tell me if they're feeling like they just have some insight, maybe. Opposite angles of a cyclic quad. I don't see a cyclic quad here, because the cyclic quad would need to have 4 points on the circumference of the circle, and I only see A and C. Who feels like maybe they could put their hand up and give us a little bit of help here with this one? Maybe point us in the right direction. Maybe you even know how to get F, and you can tell me. Who feels like they might know where to go? What do we know about this angle here? I think this one over here is also going to be F. So I think we can say that CAB equals F. Why do I know that CAB equals F? Just as an interesting, what reason would I use to say why? And I'll explain why I'm trying to say that that's F in a moment. So I think that if we have angles that are opposite equal sides, those angles are equal. So we would just say angles opposite equal sides. Or Ndudu said isosceles triangle. So I totally agree. It is an isosceles triangle. The official reason just is angles opposite equal sides, but yeah, in the right ballpark. What's going to be my next step to figure out what F is? What's going to be my next step? Just put your hand up quickly. You can just tell us on the audio, chop chop, or Orokanisa 180 minus. So Orokanisa is saying that I need to use the sum of the angles in a triangle. So if I go F plus 80, that gives me 180. And the reason is sum of angles in triangle. And then we can say 2F is equal to 100. So we took away 80 from both sides. And then we can say that F is 50. So we have this is 50 and that is 50 over there. Now, I want you to think, give me a thumbs up if you follow how I got F. Give me a thumbs down if you didn't follow how I got F. I just want to feel for the mood in the room, because this was a tricky-ish question. So I just want to see that you're with me, or if you've been thrown overboard. Zwandile, let's unmute you. What is your question?
Hi, everyone.
Hey.
I wanted to ask, how did you get, where did the 80 go?
Where did the 80 go? Okay. So
yes.
Can you see it goes F plus 80?
Yes.
And it is equal to 180. Are you happy with it being equal to 180?
I'm not sure, sir.
Okay, so here's the thing. Can you see there's a triangle here?
Yes, sir.
Okay. Now, what I was saying was, if we know that there's an F down here, and we know that this angle over here is an F. So we have this one plus this one plus this one are all the interior angles of a triangle. So are you okay with that?
Okay, sir.
Now, if I take away 80 on this side and I take away 80 on this side, it knocks that out. And what's 180 minus 80? It's going to be
100.
But now I've got two F's. One F plus another F is two F's. So what does that F have to be? Well, it has to be 50.
Yes, I understand now.
Perfect. Thank you for your question. It was super helpful. Now, what I want to ask is, what other theorems with tangent? The tan chord theorem isn't actually involved in this question, because even though there's a chord, the chord is here, but the chord needs to subtend an angle at the circumference, really, for the tan chord to come in. What is the other theorem that is involved with tangents? There's the tan chord, there's tangents from a common point. What's the third one? Who feels like maybe they can look back into their notes or help us in the chat? What is the third one? Tan radius. Yes, Annie, yes. And this is the center of the circle. And this is a radius, and this is a tangent. Now, what do we know about F? We know that F is 50. So if I say to you that OA is perpendicular to AB by the tan radius theorem, what do we know that G has to be? So we were saying, look, this thing over here is 90. What does G have to be? So think about this angle over here, the G, and the thing next to it have to add up to 90. So G would just be 40. Okay, so the first part of our learning today is in the tangent bucket. We have tangents from a common point. We have the tan radius theorem, and then we have the tan chord theorem. But yeah, Keisha, let's go to you. What is your question?
Hi, sir. It's not a question, sir.
Okay.
So in the brackets, you say tan radius. What does it say after that?
Oh, THM. Sorry, it's a shortening for theorem, like THM. Okay, perfect. Sadiq, so what I was saying was that this is the radius, right? This thing is the radius. And this thing over here, the F is a 50. This is a 50. So this big red dot over here is a 50. Now the green dot next door with the red dot must be 90. So that's why G must be 40. So this must be 40, and then this could be 50, and then together they give you the 90. Okay, so I hope that helps, Sadiq. Okay, pleasure. Let's rock and roll into a next question. So I want you to try and find me what I and what H and what K are. Now, I don't know which the best one to start with is, but I do want to ask the class, what are these two lines over here doing? What do they stand for? Does tan radius also apply to the other tangent? It does, Annie, if it's joined to the center point, yes. Okay, it means that they're equal, absolutely. So if those two sides are equal, the angles opposite those two sides will also be equal. So we can say ABD equals 70 degrees, and the reason is angles opposite equal sides. And then I want to ask you what K is. I see some answers. Keep them coming in the chat. Mdudu, Orokanisa, Brooklyn, Siwa. Okay, so clearly it's 40. And the reason is it's a triangle. So we say sum of angles in a triangle. So we know that this is 70. Okay, so we've done that part. The next thing we need to do is either get H or get I. Any ideas in the class for how we could get one of these values here? What might H be related to? Sorry, I wrote the wrong thing here. This shouldn't be 70. This should be 40. I'm having an old person moment. Sorry. So we could have straight line, but then we would also need to know for the straight line, we would need to know that, and we would need to know that. So all of those together. So it's a nice idea. You were talking about this theorem in the previous question. Yes, Mbali and Zanele. It's the tan chord theorem. So which angle is the H related to because of the tan chord theorem? Aha, yes. So let's just go over what the tan chord theorem does again. It says, I have a tangent, and this tangent makes an angle with a chord, and that chord is going to subtend or build an angle at the circumference. So it's like this one over here and this one over here that are related. And so we would say that, let me just make sure H is equal to 70, and we would say the tan chord theorem. Now, the last thing we have to worry about is I. How are we going to find what I is? What theorems haven't we used that might be relevant in this picture? What theorems haven't we used? What information is still here that maybe we could use? 70, yep. So we have this. What other bits and pieces can I see in the drawing? So we have, that's a tangent. But what I've realized is that's also a tangent, which means that BC must be equal to DC, and that's going to be tangents from common point. Now, if that's the case, if this one is equal to that one, well, then we know that BDC, what is BDC going to be? This one down here. So if these two are equal, BDC down here needs to be 70. And that's that same reason from before. I can use red again. It's angles opposite equal sides. Absolutely, Sachaba. So that's 70, that's 70. So now the question is, what is I going to be? So it feels like, again, the idea of a triangle means that these must add up to 180, and you've already used up 140. So I will be 40, and that will be sum of angles in triangle. Okay, so let's see how the group is feeling. Give me a thumbs up if you followed my thinking in that question. Give me a thumbs down if you feel a bit lost now. Just want to get a, because I can't see everyone's face, and so it's really helpful to get a feel for what is happening on your side. Otherwise, I might misread the situation. Okay. Now, even if you are struggling, remember that there's two options. The one is that we're going to do more examples. The other one is that you can always rewatch these videos, and the second time is a lot easier. Okay, let's do this one. I want you to try and help me find X, Y, and Z. And I'm just going to give you some time to fly solo. If anybody's generous, you can leave some tips in the chat about what might be involved here. It feels like there's two buckets involved here. I see a center of the circle and a tangent. I'll steal that. I'll point it out. See if you can find what X, Y, and Z are. Oh, did we do this question on Monday? Apologies. I must have. Okay. So I seem to have redone this one, but let's just write it out anyway. So Y is 90 because of angles in semicircle. So it's kind of like, here's the diameter. And so we know that the will subtend an angle of 90. And then Z would just have to be 60 because of the sum of angles in a triangle. So that would be 60, that would be 90. Now, what is the X going to be? I feel like we have to invoke, yeah, so we're going to say OT is perpendicular to AB, and that is the tan radius theorem, which means that that's basically 90. And so then X would just be 180 minus 90 minus 36, which would be 54. Sum of angles in triangle. Okay, I'll just leave that up for a moment. Maybe some of you missed Monday, but I did do that on Monday. I'm recognizing that. Okay, let me move on now. Did we do this one on Monday? Don't remember doing this one. Does anybody recognize? Okay, cool. Let's do this one. Find X, Y, W, and Z. Notice how the drawing is getting a little bit more complex, a little bit more detailed. See if you can, and after this one, we're taking a break. Our brains have worked hard enough. Where can we start with this one? This is quite a tricky one, hey? I'll give you one little hint. If you look at this, even though it's a bit hidden, this is a cyclic quad. What do you think, what do we know about cyclic quads? What do we know about cyclic quads? See if you can figure out what W is. See if you can figure out what W is. Okay, so I see that a lot of students have said the opposite angles in a cyclic quad must add up to 180. So maybe that can help us figure out what W is. See if you put your answer for W in the chat there. So this is going to be 22. Which one should we go after next? Which one do you think we should do next if we know what W is? Which one would be the next easiest? I think X is the next easiest one, yeah. So what is important about X in this part of town? So we know actually that this is a tangent here. This is actually one too. So what do we think X is? So X isn't 90, but it's got to do with 90. So this angle over here, the line, so tan radius, this is the radius, and this is a tangent. So what does X plus 22 must be 90, tan radius theorem. Therefore, X is equal to 68 degrees. So this would be, oopsie daisy, 68 degrees. Which one should we do next? Which one should we go after next? Y. Okay, let's go off Y. We want to try and get this one here. What do you think Y is? So these are tangents from a common point. So we know that this is equal to this. We know that PU is equal to PR tangents from common point. And so we know that is 68. So what is Y going to be? What is Y going to be? I think it's just going to be that, which is what? Take away 8, take away 8. It's going to be, yeah, 44. Sum of angles in triangle. Okay, last one. What is Z going to be? What is Z going to be? I'll give you a hint. We know this is a tangent. We know that this is a chord, and we know that that chord can make that angle over there. So this is the angle between the tangent and the chord. What is Z going to be? So Z is just going to be 68 degrees, and that is going to be the tan chord theorem. That's it. Okay, now everyone, we really are working at harder questions now. You notice how we had stuff about triangles and tangents, and we had, tan chord theorem. So it's important that remember that you might need to watch the video again to let this really sink in. So in Mzwandile, basically what I did was I said, look, here's a tangent, right? Here's the tangent. It's hanging out outside the triangle, outside the circle. And it makes an angle with this chord over here. So the angle between the tangent and the chord is 68. Or if I can say that it's here. This chord subtends the angle Z over here. And so they must be equal to each other. So that's why I'm getting 68 for Z. And we call that the tan chord theorem. Okay, I hope that helps one, Zile. All right, it's now, we need to really take a break. So I want everyone to turn their cameras on, and I want you to stand up with me because this is heavy brain work, and our brains need to just unwind for a second. So just join me, take a moment for yourself, and let's just take some nice deep breaths. And I'm going to breathe in, then we hold, and then we breathe out. Okay, so I'm going to start in 3, 2, 1. One more. Okay, then shake out the arms, get them nice and loose. Shake out the legs. Okay. And let's do some light rotating. See as your body relaxes around the hips. You'll notice that you slowly go a little bit further. And as you relax, you'll get complete freedom by turning out. Okay, then let's do this one. I haven't done this for a while. So cross, look up front, and then to the other side. Okay, shake out the arms again, shake out the legs, and let us do some skipping, some air skipping. So we'll do 20, and we'll start in 3, 2, 1. Let's go. 8, halfway, 1, 2. And there we go. Yeah, so it's a short one today, but we just wanted to let our bodies know that, some time off for them, for us, yeah. And then let's do a Maths 24 brain break. Can you solve either of these two Maths 24 puzzles? Can you solve any of those Maths 24 puzzles? Who feels like they can do it? It's been a while, Annie. We've been doing all the jumping jacks. Yeah, I'm a bit tired to do jumping jacks today. I don't think I would survive. So how do we make 24 with 9, 1, 5, and 5? It's a bit of a toughie, yeah? What can we do? Oh, I wish it was a 6, Sachaba, but I'm afraid this looks to me like a 9. So what are the two factors of 24 that we either normally end up with 6s and 4s, or 8s and 3s, or okay. So I say 5 minus 1 gives you 4, and then wait, 5 minus 1 equals 4 times 6. I was thinking 5 plus 1 to give you 6. And then 9 minus, there we go, 9 minus 5 is 4. So 9 minus 5 is 4. And then 6 times 4 is 24. Yes. Okay, perfect. Perfect. And what about the blue one? Can anyone do the blue ones? So it's a D, yep, 6 times 5. Oh no, that's not a 6, that was a 9. Yeah. So the line is at the bottom, so that was a 9. Can anyone do the blue one? We've got a 5 and we've got a 4 already in this one. Miguel, 7 divided by 7 is 1. And then 1 plus 5 is 6. And then 6 times 4 is 24. Or, Feliciwa, Sakanya, 5 times 7 is 35. 35 minus 7 minus 4 is also equal to 24. Yeah, well done. So there's more than one way to do the Maths 24 questions. Okay, well done, everyone. That was a nice break. I hope you feel well rested and ready for a next question. So let us go and look at, so we've done that one already. Okay, let's do this one. Can you, let's see if I can you find me W, X, Y, and Z in this drawing? See if you can do this one. Okay, so Tegovatso and Feliciwa have some strong ideas about finding Y first. And so does Sanelisiwe. And they are saying it's 49. Can we have some reasons? Why do we think that this is 49? What would be our justification? How would you prove, you say, Brooklyn agrees, everyone agrees it's 49. The question is, what is the reason? And it seems to me like the reason would be the angle at the center. You guys are going, this is half. And so angle at center is twice angle. Yeah, so angle at center equals twice angle at circumference. So that is 49, done and dusted. Sanlisiwe and Annie absolutely agree. So we're good. X equals W equals 90. Ooh, Mdudu. Mdudu, you're right. Because if that's a tangent and that's to the center point, W must be equal to 90 and X must be equal to 90. And the reason is the tan radius theorem. So that's a 90 and that's a 90. Now, what is Z going to be? Well done, Ndudu. So Yavato, why would you, what's your reasoning going to be for Z? What reason? Sum of a quadrilateral. Yes. So this isn't a cyclic quad. It's not a cyclic quad, but it is a four-sided shape. And a four-sided shape or a quadrilateral will be equal to 360. So all I need to do to find Z is say, well, minus 90, minus 90, minus 90x. And what do you get for that? No. So you can't use opposite angles for cyclic quad. The problem is that these 4 points are not on the circumference. So you need to say, actually, this is 90 here, that's 90 there, and this any quadrilateral will add up to 360. So let's unmute Masibulele. Can you hear me? Masibulele, can you hear me?
Yes, I can hear you.
What's your question? How can I help?
I wanted to know how we got 82.
82.
Yes,
Okay, we haven't got 82 yet, but if you take if we take 360 and we take away 90 and we take away 90, we've taken away 180 and we get left with 180 minus 98. Are you okay with that so far? Does that make sense?
Yes.
But now
Yes,
if you take 180 minus 98, you're actually going to get 82. Okay, so it happens to be 82 by coincidence, but you don't know that this is a cyclic quad. So you couldn't actually use the reason cyclic quad. You had to use the idea of the sum of angles in a quad. So you should say it's a reason sum of angles in quad. And this is just a general quadrilateral. Okay.
Yes. Thank you.
Perfect. Thanks for the question. Cassini says, why is W not equal to 49? The reason is that this is a tangent, and a tangent will always meet the radius at 90 degrees. So that's why. All right. So the tan radius theorem, all the tan radius theorem says is whenever you have a radius and it meets a tangent, the angle between the radius and the tangent will always be 90 degrees. So even if I had this, right? So if I had another radius going here and I had another tangent, now a tangent touches it in only one place, that would also be 90. So that is what the tan radius theorem says, is that if there's a line from the center of the circle and it meets a tangent, that angle will always be at 90. Okay, I hope that helps a little bit. Let us carry on. Okay, so here is an exam type question, and we're getting towards the end of today. So let's just take a moment really to unpack this. So it says, in the diagram below, notice I'm going to use colors. In the diagram below, two circles touch each other at the point P. So let's go and find the point P. There is the point P between the two circles. And we can make that a red dot there. It says that QPR is a common tangent to both circles at P. So where is QPR? QPR is just going to be that green line there. Notice how the use of color really helps my brain understand what's going on. Then it says, EDRC is a tangent to the circle. So let's go find EDRC. Okay, it's not going to be a tangent to both circles. It's just going to be a tangent to that circle over there. Because this one, it's a chord. I mean, it goes through there at C. Yeah, so there's that. So that's a tangent there. And then it says that RCA equals Y. So where's RCA? Oh, there's Y down here. And then it says DAC is X. Now DAC is X. Okay, well then we can maybe color this in over here. That is X. And this is a very typical exam question. It says, name with reasons 4 other angles equal to X. Now remember, X is up here. It's this one. Who would like to give me another angle in the drawing that is equal to that red dot angle? Who feels like they might have an angle which is equivalent to that? So if I look at this, what things, there's definitely tangents, there's some parallel lines involved. I must forget, actually, I've left them out. These are parallel lines here. So that is parallel to that. All right, so quite a few students are saying C2. Now, where is C2? C2, let's go hunting. Oh, C2 is down here. Why do we think C2 is equal to that one over there? Oh, it's going to be alternate angles. So C2 is equal to X. It's the Z shape. So we'd say alternate angles. And what are the parallel lines that are involved? It's going to be AD parallel to BC. So I agree. I'll even color it in a bit green. What are the other angles equal to? Either this one over here or that one over there. I'll give you a little bit of time. Keep phoning in and keep giving. So quite a few students are saying angles in the same segment. Now, we don't have angles in the same segment in this circle, but we do in this one. And you're right. I am getting the sense that this chord PD makes that angle there, and it can also make this angle up here. Let's see if I can get that. There we go. We can say that angle E is equal to X, and that's going to be angles in same segment. Okay, so we've got 2 so far. What are the other ones that we can maybe hunt? D2. I don't think D2 would work. Angles subtended by the same segment. No, I don't think that would work. What haven't we used in this question yet? What haven't we used in this question yet? That is part of the drawing, but we haven't used it. Let me see, look at the chat and see what else people are saying. B2, angles in the same segment. Okay, fine. P5. Now, what is the reason going to be for P5? Let's have a look. So there's P5. Let's give it a dot of its, well, oh, wait. I don't know if is it P5? What about, I was thinking, I think the tangent is important. What about this? D1 maybe, or what about this? If this is the tangent and that was the chord, so let's just pretend that's the tangent, you can see it going, and that's the chord. Can't we say that this angle over here is equal to that one up there? What's that theorem called? What's that theorem called? That says that this, what's that called? It's called the tan chord theorem, yes. So we can say that P1 is equal to X by the tan chord theorem. Yeah. We need one more, ladies and gentlemen. We need one more angle. P8, not P8. Not, could we say D1? No, because D1 would match with P7. What about, how about this tangent and this chord? Oh, wait, I'm lying. Am I lying? So this was an X here. Let me go back. So we've said that that was X there. Ooh, what about vertically opposite angles? Let me just get rid of all this nonsense for a second. Couldn't we say that we've already said where's P1? P1 is here. We've said that's X. Isn't this vertically opposite? So I don't know if I'm making it very clear, but I'll try and point it out here. Like this angle over here is equal to that angle over there. And we know that P1 is already X. So won't P5, now this is tricky. Well, it's hard to see because the drawing's a bit cluttered, but I think we can just say vertically opposite angles. D3, I'm afraid D3 wouldn't quite work. So I think the one that does work is that these two are equal to each other. Good old vertically opposite angles. Okay, now we're starting to get to the angles on a straight line. Let's have a look. Angles on a straight. I mean, the thing about angles on a straight line, I don't think it would be angles on a straight line. No, I think it's be vertically opposite angles. Yeah. Okay, everyone. Now, the last question was a bit of a toughie. I want you to maybe have a relook at this. From next week, what we're going to do is we're going to starting to build up to these examples, although this was quite a tough one to end. So for example, we might do a question like this next week.